Is variation of parameters. It's very easy. Just need to remember two formulas, A and B. So if for A you have minus VR, UV dash minus VU dash, and B positive. So if the question is like this, solve, you'll be given by method of VOP. So then normally you will find YC. After writing C1, C2, so one before C1 you will take as U, and other one you will take as V. And you will find UV dash minus VU dash. Okay. Then you will write A formula. So what is A formula? Integral VR by this UV dash minus VU dash. So what is my V? Sin X, and UV dash minus VU dash is 1. So it is R here is this in question. This is your R. So that is sin x by cos x. So I wrote sin square x by cos x. And B, okay. So how will I solve this? I'll sin square x is 1 minus cos square x. And then this becomes secant x. This minus cos x. So integral of secant x is log mod secant x plus tan x. And integral of cos x is minus sin x. So integral of cos x is sin x only because minus is there, so we wrote it. So this is how you find A and you find B. Finally, answer is AU plus BV. Okay, remember in A you'll have V, but in final answer you should write it with U. AU plus BV. That's how you get YP. So this method is called VOP. Next, very important, Euler cauchy equation. So when do we use this? When we have variable coefficients. Okay, see example, I'll show you question. See, x square minus 2x. See, these are variables. Until now we have only seen constant coefficients. So when we have variable coefficients, we use Euler cauchy equation. So what do? We reduce variables to constants. How? Using these equations. So here we'll take x is equal to e power z. We'll substitute and then we'll get z is equal to log x. Okay, and x dy will write theta y, x square dy will write theta into theta minus 1y, x cube d cube y we write it as theta minus 1 theta minus 2y. Okay, y is there, remember that. So now we'll solve some questions. Square d square y plus x dy minus 4y is equal to x square. Okay, this is question. So now what did I tell you? X dy we write it as theta y, x square d square y we write it as theta into theta minus 1 into y plus theta y minus 4 into y. So what is e power z? So we substitute, no? So x is e power z. So this will be e power 2z. So I'll take y common. Theta into theta minus 1 plus theta minus 4, y common. So if you wonder what is theta, so here theta is d by dz. Okay, so now this will be theta square minus theta plus theta get cancels. So how do we solve this? Until now we have seen 6 cases for what to solve these only. I'm just kidding, those will be also given in exam. Okay, so d is d by dx, right? So see theta also in the same way as d. If d square minus 4 is there, how we used to solve? The same way, using those 6 methods only we solve. So this falls under case 1, right? So this is my f of theta into y, q of x. So what is my particular integral? Yp, yc, all that. Instead of d, theta is there. That's the only difference. Okay, first we'll write auxiliary equation, which is m square minus 4 is equal to 0. So I'll get m is equal to plus or minus 2. So yc will be c1 e power 2x. But here it will be 2z. Okay, because here it is q of z plus c2 e power minus 2z. Clear? Next, yp is 1 by, okay, so 1 by f of theta is theta square minus 4. Q of z is e power 2z. So this is under case 1 where we have exponent term. So what we will put theta is equal to 2. But if I put theta is 2, I'll get 0. In this special exception, how you will be used to write? theta plus 2, theta minus 2. We split into factors and then we put 2 only here, not here. So 2 plus 2 is 4. And instead of this, what we used to write? 1 by theta minus 2. We'll write something like x power k by k factorial, right? Where k is number of times 2 is repeated. So here in my roots 2 is repeated only once. So I'll write z power k by, so z power 1 by 1 factorial. Here x, here z. Okay. So this is your. Okay. So now we have to resubstitute whatever we have put. So what is e power 2z? X square. So what is z? Z will be log x. So this is my yp. So yp is x square log x by 4 and yc is this. So yc plus yp is your final answer. So this is how you solve variable coefficients using Euler cauchy method. Okay, we'll do one more question to get clear idea. So what we should put? X is equal to e power z. So z will be log x dy theta y, x square d square y, theta into theta minus 1y. Okay, now we'll substitute. So what is this? X square d square y means this. So theta into theta minus 1 minus xd. So it will be theta minus 3, y I took common. X square means e power 2z, log x means z. Okay, this is how we substituted. Now we'll multiply theta square minus theta. So theta square minus 2 theta minus 3 into y is z e power 2z. So this is f of theta into y, z e power 2z. This is my q of z. So this is of which case? You'll find out. See. So first I'll write auxiliary equation for yc, which will be m square minus 2m minus 3 is 0. So m is equal to minus 1 comma 3. So yc will be c1 e power minus z. Okay. So here I have to substitute c1 e. What is e power minus z? 1 by x plus c2 e power 3z means x cube. So this also you have to change. Whatever you have substituted, you have to bring back to question. No, and before question also, you have to bring back yc. So you have to e power 2z, no? You should write c1 x square plus c2 1 by x square. So you have to bring back to x. See, x terms lo maatrame undalu. How will we get yp? So this is your yc is done. So yp is 1 by f of theta into q of z. It is z e power 2z. Which case is this? Case number 4, where you have exponent term and some other function. So in case number 4, what we used to do? We used to put exponent term before and put d is equal to d plus a. Here a is 2. So we'll put theta is equal to theta plus 2. Right? So theta is equal to theta plus 2. I'll bring e power. So e power 2z friend. 1 by theta plus 2 whole square minus 2 into theta plus 2 minus 3 z. Okay. Next, which case it will come on the third case now. It's like x power m case. Here m is 1. It's like only z is there. Okay. So we'll solve here. E power 2z 1 by theta square plus 4 minus 1. So I'll get plus all theta square plus 2 theta minus 3 into z. Okay. Now what we used to do? We should take least degree term common. In case 3, we'll take least degree term common. Here it is minus 3. So I'll take minus 3 common. So I'll get e power 2z by minus 3. So 1 minus theta square plus 2 theta by 3. Bringing it from denominator to numerator. Okay. So now which formula I'm applying? 1 minus, so this formula. Okay. So until how many terms? Only first, because z is there. So e power 2z by minus 3 1 plus 2z. Okay. So how will we solve this? 2z by minus 3 z plus See, I told you first only theta means d by dz, right? So theta square means double differentiation of z, which is 0. 2 into single differentiation of z is 1. Understood? So z e power 2z by minus 3 and 2 by 3 e power 2z by minus 3. So finally we have to substitute. So what is e power 2z? First we wrote, no, it is x square. So put x square, and in place of z it is log x. So x square log x by minus 3 and 2 by minus 9 e power 2z means x square. Like this you have to solve Euler cauchy. Everything is same, the same 6 cases we followed, but instead of capital D we have theta here, that's it. And theta means d by dz, there capital D means d by dx with respect to z, with respect to x. This is the only difference. So Euler cauchy is the same as those 6 cases we have studied, just you have to remember this thing. Okay, so we are done with Euler cauchy. So we are done with method of variation of parameters. Now the last thing we have to learn is method of reduction of order. This is also for variable coefficients only, but the trick here is, like, if you say in question one solution is already given and you have to find the other solution, then that is this method. This is the last topic of our chapter. So this is our formula sheet. These are the 6 cases. These 2 formulas are important. Okay, so here you have to remember that y1 of x will be given and y2 of x you have to find using this formula. U of x into this. What is u of x? This formula. Okay, what is p of x? It is coefficient of y dash, coefficient of y double dash. Like we'll do like this. Okay, we'll see one question. See this. So y is equal to e power minus 2x is one solution. That means y1 of x is e power minus 2x. It's already given in question. Okay. Then find the other solution by reduction of order. So first y1 of x square e power minus 4x. So we'll find p of x, coefficient of y dash minus y double dash, coefficients. Next, now important, u of x. If you got u of x, then write y2 of x is u of x into y1 of x. Your answer is done. You have to find this y2 of x. For that, you need this. So this formula is integral 1 by y1 square e power p dx. Okay. So what is p of x? This minus 1. So 1 by y1 square means given function square. E power integral of minus 1. So integral of minus 1 dx means it will be minus x. So in formula you have like this. So I'll get minus 1 dx. This is there in formula. So this will be e power x by e power minus 4x dx. So integral e power 5x dx, which is e power 5x by 5. Okay. So u of x you got. So what is y2 of x? E power 5x by 5 into y1 of x, which is e power 3x by 5. So simple. You just need to remember this one formula. That's it. A small thing I want to tell you, this question is not only for variable coefficients. If in some questions you have constant coefficients only, but even though one solution is already given, then also you can apply this method like this. So one solution is e power x, and what is p of x? 3 by 1. Okay, u of x is integral of square e power minus 3 dx, so which is e power 2 plus 3 5x. So you got something, and y2 of x is easily into over. So what I'm trying to say is, not only for variable coefficient, even if you have constant coefficients, if one solution is given, you can apply this. Here general solution is yc plus yp, no, here it is ay1 plus by2. Okay, y1 is already given, y2 you will find. We should write like this final answer. Here I'll write general solution is equal to ay1 plus b y2. Okay, instead of yc plus yp, in this reduction of method in this method we'll write like this. This method, one important model I think it is asked in previous year. So you have to verify first. How do you verify? See, this is example. If y is equal to f of x is equal to e power 2x, I told you y1 of x they'll already give, right? But here they're not telling it's a solution. You have to check whether it's solution or not. So how do you check? So you find y dash, you find y double dash, e power 2x, which is 4 e power 2x. And now you substitute in the question. If it's satisfying, then it is a solution, right? That is what a solution means. So 2x plus 1 into y double dash is 4 e power 2x minus 4x plus 1 into y dash is 2 e power 2x plus 4y, 4 into e power 2x. Now see, solve them. So 4 e power 2x into 2, and here you get 4 e power 2x minus 2. So I think this cancels, and 1 is here 4, and here you'll get minus 4, and minus 4 2s are 8. So 4 plus 4 8 minus 8. So it's getting cancelled, it is becoming 0. So therefore y1 of x e power 2x is one solution. Okay, now you have to find y2 of x, right? Find the and find other solution. So let y1 of x e power 2x, you should find p of x, which is coefficient of y dash minus 4x plus 1 by 2x plus 1. So u of x is 1 by y1 square, so e power 4x into e power p dx minus p dx. So integral e power minus 4x e power, I have to find integration of this. So let it be like this. So how will I find integration of this? We should use trial and error method, which means, see, what is derivative of 2x plus 1? If 2 is there, I would have written easily log 2x plus 1, right? So if it's like this, so 2 by 2x plus 1 integral. What is it? Log 2x plus 1. Because integral of f dash of x by f of x is log f of x, right? So, but I don't have 2 here. I have something like this. So by trial and error method, if I check 2, see, put here 1. Next I put 2. Then 2 into 2. So it's satisfying. See, 4x plus 1. It is satisfying. So this is equal to this. So by trial and error method, you have to find this into e power 2 plus 2 by 2x plus 1 dx. So which will be 2 dx means 2x. This will be log 2x plus 1 dx. So what is a power m into a power n formula? So I can write it as e power minus 4x plus 2x minus 2x. So this I can write as e power minus 2x into e power log 2x plus 1. Because it is natural, we have another formula also, that is e power log a. We can write it like this, right? So this I can write it as, I can directly write like this, e power minus 2x into this. So e power minus 2x into 2x plus e power minus 2x. Okay. So this I'll apply uv now. So this will be my u, this will be my v. So this is v and this is u, exponent term plus e power minus 2x by minus 2. So u integral v minus u dash 1 integral of e power minus 2x is by minus 2. So x into e power minus 2x by minus 2 minus integration of this. So I'll bring this outside, plus 1 by 2 integral of this again. So now 2 cancels, x e power minus 2x plus this 2 cancels, and e power minus 2x by minus 2 plus e power minus 2x by minus 2. So this is your final answer. So this is how you do reduction of ordered method question. And lastly, so even though it's not there in a syllabus, they're asking in exam. So ma'am told to prepare Wronskian, which is like linearly dependent and independent functions. So basically, they'll give you 3 functions. You have to find that. You'll write the given functions, and next row you'll write their derivatives, and next again the derivatives. You'll find that if it's not equal to 0, then they're linearly independent. And see, show that 1 sin x cos x are linearly independent. We found that, which is minus 1, not equal to 0, therefore linearly independent. So if you get is equal to 0, then they're linearly dependent. So this is